That means that gives us the rate of change of y with respect to the change of x. Therefore, the geometrical meaning of dy dx is the slope of the tangent to the curve y equal to fx at the point x, y. Already we have learned, or I have discussed, how to find the derivatives of a given function with respect to the independent variable. Now, the question is why we need derivative or differential coefficient of a given function. That means meaning or interpretation of derivative. First, y is function of x. Already it is discussed. Fx is taken to be single valued. Now, corresponding to the change of x, that is x takes the value x plus delta x, and corresponding changed value of y is y plus delta y. That means delta x change in x, delta y change in y. Next, we have considered the ratio or quotient delta y, delta x. Now, if we write this, that means quotient of change of y to change of x. This is the rate measure. Rate measure. That means that gives us the rate of change of y with respect to the change of x. Now we have different meanings of dy dx. First, we take geometrical meaning. Here, one thing, this is the average change, and when the change of independent variable is very small, then we call this ratio or this quotient as dy dx. Since change in independent variable is very small, we call this is instantaneous change. This is the rate measurer or rate measure. Then we consider geometrical mean. Say y equal to fx is a single valued function. We can take this diagram. Let y equal to fx be the curve. Let PQ be 2 points on the curve having coordinates. This is x, y, and this is x plus delta x, y plus delta y. 2 neighboring points. Now we draw perpendicular from the straight line L cuts the curve at P and Q points, where PQ are points on the curve, also they are lying near to each other. Now after dropping perpendicular from PQ on the x-axis, say PL and QM, then PR perpendicular on QM is drawn, so that we get triangle, rather right triangle PQR. Now if this straight line make angle theta with the axis, then from geometry we see this angle RPQ will also be theta. Therefore tan theta will be tan of angle RPQ, that is equal to, with respect to this angle, tangent, that means RQ by PR. Now RQ is equal to MQ minus MR. And PR, this will be a rectangle, therefore PR will be equal to ln, that means OM minus OL. After putting these coordinates, we shall get this is equal to delta y by delta x. Now if Q approaches P, when Q approaches P along the curve, then delta x tends to 0. And this angle will be something other angle which is made by this straight line L, and this straight line becomes tangent. You see, when Q approaches P, that means the straight line will be like this. The straight line will be a tangent. I write here. Then L will be tangent to the curve. Therefore, making angle psi with the x-axis. Therefore, limit delta x tends to 0, delta y by delta x is equal to tan theta will be tan psi, and this is dy dx. Thus we get the geometrical meaning of derivative dy dx is equal to tan psi. That means dy dx is the tangent of angle psi which is made by the tangent to a curve y equal to fx at the point P xy. Thus the geometrical meaning is slope of the tangent at P to the curve to the curve. Let us repeat. Therefore, the geometrical meaning of dy dx is the slope of the tangent to the curve y equal to fx at the point x, y.